Good day, folks. Welcome to my YouTube channel. Guys, please do not forget to subscribe on my YouTube channel and like all my videos and watch all the videos and share with your friends and family. And I would like to thank you for your support. I've seen your subscriptions and your likes and your comments on my videos. Please continue to do the right thing. Guys, this is a lesson based on acids and base reaction. Now, this is a trick, guys, for the 7 to 8 marks question that is difficult at the end of the acid-base question in grade 12 question paper. So this is a trick, guys. In the 9 mark, in the 7 to 8 mark, to 10 in fact, to 10 mark question, this is the trick to answer that question. Just watch carefully and go back if you do not understand, and rewind the video all the time if you do not understand. Let's cut the chase. The acid-base reaction, guys, there will be a limiting and an excess. We're looking at the case where there's a limiting, there's an excess. Guys, if you look here, we have an acid and we have a base on different beakers. So if you look at the amount of an acid, it's quite big than the amount of a base. So if we mix them together on one beaker, surely the acid will be an excess here because of the amount. It has a bigger amount than the base, so there will be an excess. So when you add them both, you pour all of them in this one beaker. So what's going to happen? A certain portion from a acid will neutralize the base, but in this case the base will be used up completely. This base will be used up completely. So if it's used up completely, it will be what? A limiting. So as I've mentioned earlier, a certain portion from an acid will remain, so a base will be what? Will be an excess. So in this here, this is where the neutralization occurred. So these are the required amounts from both acids and a base. So these are the required amounts that reacted. So this is neutralized. They both neutralize. So acids and base, they neutralize, which is they react. They cancel each other here. So this is the amount that did not react from an acid. This is an amount that did not react from an acid. So we call that amount, it's a what? It's an excess. So mostly the long question, the acids and base, they want the concentration of this, or they want the pH of this. Now, another thing that is important, this solution, and now it becomes acidic because what is more here, it's a what? It's an acid more than the base, and then excess here is what? Is an acid. So if this is acidic, we can therefore conclude that its pH will be what? Less than 7. So something that is acidic, the concentration of hydronium ion, it's greater than the concentration of OH minus, which is the concentration of an acid is greater than the concentration of a base. That's what it means there. So guys, in these questions, there are steps that you need to follow when they ask you. Let's say the question, it says calculate the concentration of an excess. So we know which one is an excess here. Then excess here is what? Is HCl in this case. So here are the steps that you need to follow. Step number 1, you calculate the number of moles of a base and the number of moles of an acid from these beakers. The number of moles. So calculating the number of moles, we call that, those are the amounts available before the reaction. Amounts available, or we call its initial amounts. Those are the initials. So what do? That you depending on what you have, so the amounts available, they need to be in what? In number of moles. They need to be in what? In moles. In moles. For instance, if you are given the concentration of this, the concentration of a base and the volume of a base, and here you are given the concentration of an acid and the volume of an acid there. So we'll use the formula that says C is equal to N over V. You have the volume and the base, so you want the number of moles there. So those are the number of moles of an acid, and these you calculate for both, for an acid and a base. Step number 2, what do? You do what we call, it's a mole ratio. That mole ratio, what do you want with that mole ratio? We want the amounts reacted. So I wanted the amount reacted of what? Of HCl, which is the HCl now, it's a what? Is an axis. Because calculating the amount reacted of HCl here, it will help me to achieve this question, to get an excess. So step number 3, I calculate what? An excess. What react? An excess amount of what? Of HCl. How do you do that? You say the number of moles of an excess is equal to the number of moles initial or available minus the number of moles reacted. Remember, you calculated the initial amounts or the number of moles available, so you will say the number of moles available minus by the reacted amount of an acid. You have an excess there. So step number 4, from that, now you have an excess. You go, this is the final thing that you have to do. Remember the question, it wants the concentration of an excess. Guys, those bold brackets there, they mean concentration. So you will say the concentration of an excess is equal to number of moles, but which number of moles? The number of moles excess is equal to the number of moles excess divided by the volume. Remember, this excess, where is it? Is in this total volume. So this total volume, you add this volume plus this volume. So here, it will be a total volume. Total volume. So if you are given both acid and a base, the acid and a base in an aqueous solution or in a liquid form, so you have to add the 2 volumes. You have to add the 2 volumes. So here you will say the volume of an acid plus the volume of a what? Of a base, and then you get the concentration there. You get the concentration that remained here, which is this concentration. You get the concentration of this. That's the question, in mole per dm3. Don't forget the units. Now, if the 5th step here will be, you answered this question, right? You answered this question. But now, if the question was saying here, calculate the pH of the final solution. The pH of the final solution here, this is the final solution, guys. Now the pH, when they want the pH of the final solution, they will say calculate the pH of the solution at the end of the reaction or at the completion of the reaction. So they wanted the pH of that axis. So you go these steps as if you're calculating the concentration. You do step 1, step number 2, step number 3, step number 4, but you, with this question, you do all those steps, but you take one step further. When you calculate the pH, you use this concentration that you got here, and since it's a hydrochloric acid, you know, since it's a hydrochloric acid, it's a monoprotic acid. So calculating the pH, you need the concentration of what? H3O plus. So since the HCl is a diprotic acid, So the concentration of HCl is equivalent to the concentration of hydronium ion, because the ratio between them from the equation HCl, when you dissolve it in water, the ratio between them is what? Is 1:1. So the ratio here is 1:1. So the concentration of these will be equivalent. So the concentration that you have here in this step 4, it will be equal to the concentration of hydronium ion. So therefore, you can calculate the pH by using that concentration of HCl. But that's not always the case. So if it was a sulfuric acid, so the concentration of hydronium ion is 2 times the concentration of sulfuric acid if it was a diprotic acid. If it was a triprotic acid, the concentration of H3O plus, which is the hydronium ion, it's 3 times the concentration of the phosphoric acid. I hope you get that. Those are the basics, guys. Please rewatch the video if you don't understand. Thank